So, hello and welcome to today's Range 4 webcast. Today, our guest speaker is Fraser Chadburn from IBM, and we'll be talking about requirements-driven quality management. Over to you, Fraser.
Good afternoon. Welcome to this joint webinar with Ranger 4 on requirements from Venus, testers from Mars, exploring low-cost ALM options with Jazz. My name is Fraser Chadburn. I'm a technical specialist with IBM Rational in the UK. So in this webcast, we're going to look at some of the fundamental interdisciplinary communication issues that development organizations face and their cost implications. There are, of course, cost implications both of doing something to resolve these issues, but also not doing anything. So we'll touch on both of these aspects. At the end, I'll explain some information around licensing options in Jazz that may surprise you. And my demo will actually focus on regulated industries, but the value of the course is much wider than this. So let's start by looking at the solar system. The first test is whether you can name the first 4 planets. When I was growing up, there were actually 9 planets in the solar system, and the furthest one was Pluto. There are now actually 8 planets because they discovered a few more and then decided to reclassify them. The thing is, Pluto is a long way away, and therefore we know very little about it. This is one of the problems with the solar system. The distances are huge. This picture in the top right gives us a better representation. Although the scales used for distance are different from the scales used for size. With this little dot here, this little red arrow, pretty insignificant it seems, as attested by Monty Python's Galaxy song, which I'll come to in a minute. Hopefully you've spotted Earth by now. Here we have closest to the Sun, Mercury, who's the god of commerce, Venus, the god of love, and then to the right here we have this smaller planet, Mars, the god of war, and then of course we have the Earth, which is the planet of commerce, love and war. This big thing on the left is called the Sun, and the speed of light is actually 300 million meters per second, which means it takes around 8 minutes and 20 seconds for the sunlight to reach us. In fact, the Sun could have exploded by now, and we won't know anything about it for 8 minutes. Even traveling to planets takes a long time and costs a lot of money. We have to spend $2.5 billion to build a scientific exploratory system to reach Mars, for example. It also means when we look at the stars, all the information we see is out of date. So, why is this relevant? Well, for many people in their development organizations, their worlds are actually like this. The requirements are written on a different planet from the developers and testers. A tremendous amount of effort is spent on building and integrating specialist instruments to send information to and fro. And the information that everybody is looking at any point in time is already out of date. This has huge implications for their projects and perhaps why the majority of projects actually fail. If we actually look at some of the industry metrics, the conclusions are quite staggering. Errors detected late in the maintenance phase, for example, can cost 200 times more than those detected in the requirements analysis phase. 41% of projects are failing to deliver the expected business value or return of investment. And our products are getting too late to market, which means that we lose market share. So what we're going to do here is have a look at a new universe in terms of development tooling. And I'm going to try and do this demo. I'll just switch to my demo sequence. We're going to do this demo without mentioning any product names. Something I will mention though is Jazz. Jazz, as well as being the community site where IBM Rational is developing its tools in an open way and providing lots of information. Jazz is the platform on which its solutions are being developed now. And this highlights some of the changes in the world. For example, in 1983, when the Galaxy song was written for the meaning of life, we had things like encyclopedias. People used to come to your door to sell them. Nowadays, we can just do an instant search to find information, and everything is up to date, accessible, and we get views from different people. Why is this relevant? Well, Rational Jazz platform is built with the internet as its inspirational, and although there's a server running here, I can access all the tools entirely through a web client. So we'll start in Galactic Central Point here, and I'm going to log in as a user. Obviously, we're not letting anybody see information. We have to have proper authentication. The rational user here is actually one of the gods, and he has access to quite a lot of the projects. The core of Galactic Central Point is this notion of a dashboard, and what the dashboard is doing is providing live, real information, live, real status information about the project, so we can see kind of the work items and what states they're in. There's a widget here. I can say, well, you know, which work items is John working on, and some click-throughs allowed to run that query. I can go back and forth in the browser, and I'll just refresh it. So we can actually form these dashboards using any number of widgets that are installed with any of the applications. The quality management application here, for example, has something like 127 different widgets, all showing or mining real live time information about the status of our project. So the information we see here is up to date and the latest, and we can do things like look at the plans. So a plan is actually a live, it's a set of work items allocated to a particular schedule, and we can view this in a number of ways. Again, we've actually got users here, and we can see the progress or status. For example, Tony is actually ahead of schedule, whereas John is kind of behind schedule, according to the amount of work that he's been allocated that should have been done by this stage. We have a number of views here, so like a Gantt chart view, classic thing, a ranked list. This becomes important in agile methodologies, where prioritization becomes a critical factor. A task board. This is showing the status of the work items. We can move stuff and change its status. And traceability. So let me, in this view, we see a table and it's showing, for example, this work item is implemented by these requirements, tested by this test case, and affected by defects. We've actually annotated this table to say, well, where a defect is affected by a test case, we get this failure thing coming up. So it's quite useful. If I go back to the planned time view, this is quite similar to the work breakdown view we saw earlier, but we're showing load. This is how much time we've got within this particular plan period. So if I take an unassigned task like this one here to test the infusion pump parameters and drag it to Tony, you can just see his load went up. So what we can do with this tooling is effectively manage information live. We're not sending around spreadsheets or wasting time with out-of-date information. Everything's correct and everything's part of everyday work. So I'm going to quit Galactic Central Point now, and then we'll just review these 10 factors as to why projects fail. These are taken from work by Capers-Jones, who's published a number of books on the issues, but obviously they reflect common things, common research across multiple people over a large number of times. So inadequate progress tracking, inadequate costs and schedule estimating are number 3 and 4 in this particular list. And that means that in 85% of projects, inadequate progress tracking was a factor, and 80% cost and schedule estimating was a factor to why the project failed. So pretty significant implications, and we've seen some of the functionality that we can address in the JAS platform to help solve these issues. But they're not the number one issue. So the number one issue here is in Venus. Venus is the god of love, where promises are made and promises are broken. So let's go to Venus, which is the requirement management application in the JAS platform. And I'm going to log in as Susan. Who is a Venetian. You'll notice the Venus It looks a little bit like Galactic Central Point. Susan on the All Projects page is presented with a list of projects she has access to. We also have the concept of dashboards that she could navigate to. Let's actually look at the requirement artifacts for this infusion pump project. We can start to understand some of the capabilities in the requirements management world for managing complexity. We have folders, classic folders we can put things in. For example, I put all these glossary terms into this folder, and we put use cases and actors into this folder. Another way we can organize requirements is in something called a module, which is like a document-like structure. So we've actually collected all the stakeholder requirement needs into a module here called the infusion pump stakeholder requirements. And in fact, this was imported from an external source, a Word document. We can import requirements from multiple sources, including text documents, CSV files, and also this XML-based interchange format called Recif. If we navigate to the module, we can start to look at it in more detail, and the document-like structure will start to come across. We can see that on import, actually, we've done something to break that single document into multiple elements. So this is one of the core components of good requirements management, which is having granularity. Of course, having brought it in, we can do things like baseline the module. We can also, create documents quickly for people to send to people with or without comments or attributes. As well as breaking down the requirements, we've also started to categorize them, or these artifacts, we've started to categorize them. So if I look at add in the artifact type as a column, for example, we can see that some of the artifacts are headings and information only, while others are actually formal stakeholder requirements. And formal stakeholder requirements start to have things like priority attributes and status associated with them. We don't need to track those for headings. Let's add some more columns here. I'll actually add a column for comments and a column showing the priority. And I'll reorder so that I can see the artifacts with comments. So this highlights another aspect of the JAS platform, which is collaboration, as well as audit trails, of course. Here we can see a discussions occurred on this requirement. The requirement says the device will continue to operate when unplugged from the mains electricity supply. And the comment discussion has basically been around trying to improve this requirement, perhaps put in a time boundary on it. So let's correct it. I'll put up to 4 hours. I'll just add a little bit of clarification here. Making this a glossary or taking an existing glossary term. Notice here that when I began to edit, a lock was taken, and when I clicked away, the lock was released. So the granularity here enables us to do things you can't do at the document level, which is have multiple people working on the requirements in parallel in a big team and having the flow. So the granularity allows us to kind of move to a more fluid evolution of the requirements, and we can start to do things like prioritize those requirements. And decide how to iteratively develop them, because we might not develop all of the system at the same time. If we have a view like this, we can actually save it. So let's save it as a useful view. So we come up with a better name, I guess. I'll make it a shared view so everybody can see it. And since these attributes are shared, I'll also make it usable in all modules. So it's now in the list, and we can click between views based on the type of work that we're doing. As well as showing attributes, comments, and other information. We can show links. So this has now got a column showing satisfied by relationships. And what it's telling us is that the requirement that we change is actually traced to a system requirement, and that the systems team is now planning to meet this requirement by using solar power. In fact, let's have a look at this system requirement or business requirement. And again, this is in another module. The views, some of the views are shared here, some of the views are specific to this module. If I wanted to, I can actually establish traceability by dragging and dropping between modules. So very easy to use. Let's return to the system requirements. Another thing to think of is that the links or the relationships between these artifacts can also be explored graphically using this thing called a links explorer. So here we see that this system requirement actually traces to 2 stakeholder requirements. We can also see links to other artifact types. So there's actually some risk analysis being developed here by another member of the team. And we would expect over time that this may actually have an influence on this solar power requirement. Maybe it's not safe, maybe it is safe. So there needs to be some discussion between these specialists on the project. We can also see on the links explorer that actually the links go beyond the world of Venus, where promises are made and promises are broken, into the world of Mars, which is Mars is the small planet that always gets squeezed at the end of the life cycle, where tests are done. And we can see that Tony's working on a test case on Mars. This feature here, or this view of the test case, is something called a rich hover, and is a feature of a web-based open standard called OSLC, or Open Services for Lifecycle Collaboration. And what that allows us to do is to view information in other worlds without having to navigate to that world. So we don't have to write, if someone emigrates to South Africa, we wouldn't have to write a letter to communicate to them. We could actually, nowadays, we can just go on the web and we can do a video conference. So this is the new world where there's less, where everything's instant. So that's some traceability outside of the Venus worlds, and you can see some other examples here. So there's some galactic central point links here. So these are defects that have been raised against requirements. We've got work items that are implementing requirements, sets of requirements. And we have a view here called validated by test case that's showing us how the requirements are validated by particular test artifacts. And this is quite interesting because the icon here is actually reflective of the current state of that test case, and we can see which tests are passing and which ones are failing. In terms of change, this suspect links view is another interesting area to explore. If we scroll down the bottom here, we can see that the system requirement that linked to the requirement we changed has actually been flagged as suspect. What it means is that the requirement that we're traced to has changed since that link was established. And because that requirement has changed significantly, it means that we need to evaluate whether we need to change the system requirement. We can navigate to view that requirement. We can look at the discussions on that requirement. We can also, if we actually open the element up, have a look at its history. So we can see what changed, who changed it, and when. So those are the changes we made. We changed the priority as well. So this is about the flow of information between teams and between different disciplinary people. Actually, they're both they're in different teams, but they're both in the planet Venus. So let's close that and just have a quick review of where we're at. So we started off in Galactic Central Point, where we saw how we can improve progress tracking, cost, and schedule estimating. And then we've just had a look at Venus, where we can start to manage issues associated with changing requirements. Because actually changing requirements can be a good thing, because it means building the right system. What we need is ways in which we can manage the change of those requirements so that people are automatically notified of the things they need to know about. And what we're doing here with the platform is providing up-to-date, real live information accessible through a web client. So that leads us to number 2 here, which is in 90% of projects that fail, inadequate quality control and poor quality measures were a significant factor. So let's travel to Mars now, the land of quality management. And we'll log in as Tony, one of the testers. So again, the quality management world actually looks quite similar to Galactic Central Point and quite similar to Venus. We can tell we're here because of this text in the top left. And let's have a look at the testing dashboard for the infusion pump. This is providing live real-time information mined from the Jazz team server and the applications that are installed. In this plan requirements for coverage, for example, this isn't a picture of Mars, it's actually a pie chart that tells us our completion of test cases against requirements in this particular plan. If we look along the top toolbar here, we can start to see some of the capabilities that you can do on Mars. So in Mars, we do things like creating test plans that map to sets of requirements. We construct test cases and test suites, test scripts. We can combine those test scripts into suites. We can manage lab resources or customize this to fit our lab environment so that we can, if we have scarce resources, we can plan and organize those better. We can link tests to builds, software builds that are done automatically, perhaps regression test suites that are constructed through automated test scripts rather than manual ones. And we can perform manual execution or set up scheduled jobs to do the testing. And of course, as well as the dashboards, we can report on this through the use of document style reporting. There are 2 other things in this toolbar. One is requirements and one is change requests. So these are like the space ports for the planet Mars, and the requirements are coming in through OSLC from, in this case, 2 different sources. One is actually a DAWS database, and the other is the Jazz Team Server's requirement management application. The change requests here are coming in from the Jazz application through OSLC. We can see in the widget here that Tony is actually been assigned a task. So we'll navigate to that task and just have a look what it says. You can see some discussion. So Susan's already actually sent an email to Tony. See, Tony's a Martian. Some of the text here was automatically populated, and there's some links on this task to other artifacts. So the task is linking both to the requirements in Venus, where promises are made and promises are broken, and the test case in Mars, which is a small planet at the end of the life cycle that always gets squeezed. So what I'm going to do is actually navigate to that test case. And we're just going to have a little look at Mars in a little bit more detail. So a test case is actually part of this test plan. It's owned by Tony. It's currently under review status. A test case can be linked to test scripts, and test scripts can be automated. Script type can be automated or manual. This is actually a manual test script, so let's have a look at what the actual test is. And I'll expand this to full screen. So the way we're going to test this requirement, which we looked at earlier, which is the infusion pump shall use solar power for backup power, is to plug the unit in, check that it's working, unplug the unit, and then check that it still works. Okay, this step's actually quite vague. So what I'll show you is how we can reuse other test scripts. So what I'm doing is dragging in something, a previously defined set of steps. So we can essentially easily assemble tests using kind of bricks that we take from other, or we've assembled over time. So what we'll do is plug it in, check that the pump is working, unplug the unit, okay, check that it works again, and then we'll save that. Here you can see the requirement is actually linked to this test step. So if we pass this test step, the requirement would pass. In fact, Tony can navigate and look at that requirement. And if he wanted to, he could see exactly how that requirement has changed. Actually, it used to say battery power, and it's now saying solar power. Okay, so finally, let me just redock this. Let's talk a little bit about quality management. So the reason it's quality management is not, rather than test management, is related to some other aspects of quality. So firstly, the fact that we can go to requirements and we can help improve the requirements definition work, or actually perform the reviews and requirements work on Venus, is an acknowledgement that quality management goes beyond just test. And also, there's a recognition here that quality management is about improving reviews and gate cycles. So we can actually do things like establish formal reviews, sign off, associated e-signatures. Now this is important if you have work in a regulated industry. If you want to remove this, you can do so, but it's there out of the box. So finally, just to close the cycle, what I'm going to do is just run this test. I can run it offline, I can run it online. I'll run it against the test plan, and we'll simulate going through running the test. So we plug the unit in, it powers up. We start the infusion pump application, set the channel to 1, press the load button. Press the load button again, check the right amount, unplug the unit, start the unit again. What we're going to do is say fails, and then I'll fail all the remaining steps. Show the result. So we captured all those test results are automatically captured in the tool, and we can view previous result runs. Be captured here, and I'm going to associate actually this test failure with a defect. So this defect's coming from Galactic Central Point. This is an OSRC interface to create the defect. I'll assign it to the infusion pump project. I can use some features like this @ symbol here to kind of send an email. It's getting hot down here. Hopefully you can still see it. So at this stage I've raised the defect. I've just got a window pop up, so let me just get rid of that. The defect's been raised, and you can see on the defect that actually we've got links to Venus, where promises are made and promises are broken, as well as Test, which is a small planet at the end of the cycle that always gets squeezed. Navigating to Galactic central point, yeah, which is what I was doing. We can start to see some of the feeds here, like a recently created test case. Information's been put on the feed, and we could start to go to the plan and allocate who's going to actually work on that defect. So at this point, I'm going to end the demo. So we've covered how we can deal with unstable changing requirements. We've covered how we can improve the quality control and the measures by which we satisfy or test the system. And we've seen how we can improve the progress tracking, cost and schedule estimating of our projects. I'm going to return to here. Let me just close that window. So to summarize, just remember that you're standing on a planet that's revolving and revolving at 900 miles an hour. I think the main thing is that the IBM view is actually, if you really want to get your system to work, you have to think beyond just a single planet. And actually the acceleration of a project comes from a combination of getting multidisciplinary team to work together to satisfy the needs of the customers. So fundamentally what we're talking about here is actually breaking down the silos, breaking down the barriers between teams, and providing with the tools and technology to collaborate effectively with minimal effort, including not needing to install any tools on their clients, and being able to automate parts of the process based on the roles in which they log in as. So all the technology that I showed you there, the connection between the worlds, is supported through something called the Open Services for Lifecycle Traceability interface. So the different worlds essentially can publish their artifacts like requirements, defects, as URLs. And OSLC compliant tools will be able to consume the services from other tools, as well as publish the services that they're going to deliver, removing the need actually for peer-to-peer relationships between tools. If you go to openservices.net, you can find a little bit more about this. It's an open standard. Finally, then, just to summarize, I've talked about the cost implications of not fixing the issues. So I just want you to get across some messages about, I'm not going to tell you the cost of the tools, but what I will is tell you how the licensing works. Because I said that I was going to mention Jazz at the beginning, but I wasn't going to mention the products. And the reason for this is that all the products, all the core Jazz products actually share this work item planning dashboarding feature. And you don't need to buy additional licenses to access that functionality. Secondly, all the Jazz products allow read access to the other Jazz applications. Because what we talk about in proper team-based collaboration is reducing or removing the barriers between people and disciplines. Thirdly, everything I actually demoed was done with a single license type. So Rational, Susan, and Tony only had quality professional licenses. And with quality professional licenses, providing that the user has the correct role, and that's something you determine, they can make edits to the requirements. So if you actually have people who are both writing the requirements and writing the test, they don't need an additional license. So there are other applications we have. So Team Concert takes that work items and planning and allows you to perform complete software configuration management, including things like streams, change sets, parallel working, and the rest, including build or linking with build engines. And then there's a solution called Collaborative Lifecycle Management that covers all of those applications, the three that I showed you, plus all of the configuration change management to take those defects and perform fixes. If you want to find out more, because that was an extremely quick look at Jazz licensing, if you go to jazz.net, this website, you can see how Rational is developing its tools today. If I just go to the root page, for example, we can see that there are a number of point products, including Rational Quality Manager, which is the combination of that I showed you, and some solutions. If we look at Quality Manager here, we can see a lot of information is available, including how you can download it. So the approach here is actually, we actually use the Rational products to develop the tools. Our approach here is complete transparency, including, for example, if I go to what's happening here, and we have a look at the dashboard, you'll notice that the dashboard that I'm now viewing is actually Galactic central point from the perspective of the quality manager team. Something which is also quite useful is search. So you can see how many times the Galaxy song came up in any work items. Well, there's quite a lot of galaxies, but not a lot of Galaxy song. So complete transparency, and actually we're ahead of schedule. Okay, at that point, I think we'll go back to questions and answers.
Great, thanks, Fraser. I really enjoyed that. We have had one question from Johan. It is, which version of the CLM software are you doing the demo with?
This is the 406 suite. So if I, where was I? Where was Jazz? Yeah, it's 406.
Great. So thank you very much. I don't think anyone else has got any other questions. So thank you, Fraser, for for your time, and we shall say goodbye to everyone.
Okay, thank you.
Bye, everyone.